Alright, good morning. Welcome to the class. Today we're going to have a look at the second part of C1L4. We're going to talk about two other types of compounds, which are amines and amides. During a severe allergic reaction, the body immune system overreacts to the presence of foreign substances. The allergic reaction causes tissues of the airway to swell and the lungs to fill with fluid. If not treated quickly, this severe reaction can cause death. The most common treatment for severe allergic reactions is epinephrine, also known as adrenaline. Epinephrine is a hormone produced naturally by the adrenal glands. The hormone molecules contain a functional group called amino group, which is /NH, as shown here in figure 1. Most people who have severe allergies to common substances such as bee venom or peanuts carry auto-injection syringes filled with epinephrine with them at all times, which is shown here in figure 2. Amines are one class of organic compounds that contain nitrogen. An amine is derivative of ammonia in which one or more of the hydrogen atoms are replaced with alkyl groups. Amines are classified as either primary if one alkyl group is attached to the nitrogen atom, or secondary if two alkyl groups are present, and tertiary if all three hydrogen atoms in ammonia have been replaced by alkyl groups. So here table 1 lists some common amines. Amines generally have strong, often unpleasant odors, sometimes described as fishy. Many amine odors resemble ammonia. For example, urine contains amines that comes from breakdowns of proteins. So all those associated with decaying animals and human tissues are caused by amines, such as putrescine and cadverine. Notice that these compounds have an amino group at either end of each molecule. Aromatic amines are used to make dyes. Since many of them are carcinogenic, they must be handled with great care. Okay, again, we need to learn how to name and draw amines. Consider the primary amine with the structure CH3NH2, which is shown here in figure 3. Using the opaque naming system, this molecule would be named by adding the amine suffix, which is /AMINE, to the name of the chain or ring to which it's attached. Also note that the /E needs to be removed before this name, given the name methenamine. Which is shown here in figure 3. Methenamine. Also, alternative names for methenamines are methylamine and aminomethane. Both of them, all of them are acceptable names. Also notice that in table 1 here, the opaque name for a aromatic amine consisting of amino group attached to a benzene ring is called aniline rather than benzamine. To name a secondary and tertiary amine, begin with an amine name based on the name of the longest alkyl group. We use the locator N to indicate the attachment of additional chains to the nitrogen atom, just as we use a number to indicate a specific carbon atom. For example, amine with a ethyl group, a propyl group, and a butyl group, each bounded to a nitrogen atom at carbon number 1, is named N-methyl, N-ethyl, propylbutane 1 amine, which is shown here in the first structure formula. So this compound here is called N-ethyl N-propylbutane 1 amine. As we have already read, some compounds contain more than one amino group. A molecule of cadvarine, for example, is a 5-carbon chain with amino group at each end, whose chemical formula is NH2, CH25, NH2. This type of compound is called diamine. So cadvarine's UPAC name is pentane 1,5-diamine, which is shown here in the second formula here. Did you get it? Okay, have a look at the naming schemes. And next we're going to do a practice on how to name and draw amines. Okay, next let's have a look at a tutorial of naming and drawing amines. Let's consider sample problem 1 here. Naming amines from their structures. So we are given 4 structures of compounds. Could you name each of the following amines according to the UPAC system? So I'll give you some time to do this by yourself, and after that we'll have a look at the solution together, okay? Alright, let's have a look at the solution of each of the compounds. Compound A, the longest carbon chain, is a propyl group whose terminal carbon atom is bounded to the nitrogen atom. This is only alkyl group attached to the nitrogen atom, so the compound is a primary amine, right? The compound's name is propan 1 amine. The second compound, this compound is secondary amine with a pentyl group attached to its second carbon atom and methyl group. The amine's name is based on the longer group, the pentyl group. So the name of the compound is called N-methylpentane 2 amine. Did you get it? Compound in C, we have a benzene ring here. The root name for amine attached to the benzene ring is aniline. There's also a substituent methyl group on the third carbon atom. The name of the compound is called 3-methyl-aniline. The last one. This is a tertiary amine whose longest carbon chain has 4 carbon atoms. Butanamine. The 2 substituents are a methyl group and an ethyl group. The compound then is named N-ethyl N-methyl-butane 1 amine. Okay, do you have any questions here? No? Alright, then let's have a look at the reverse process. This time, if we are given the names of amines, could you draw the structural formula of each of the amines here? Again, I'll give you some time to have a look at this by yourself, and then we'll have a look at the solution together, okay? Alright, let's have a look at the solution together. The first one, a primary amine, right? Primary amine has 1 alkyl group attached to its nitrogen atom. Then this amine is called ethanamine, whose formula is CH3, CH2, NH2. The next one is a secondary amine, has 2 alkyl groups and 1 hydrogen atom bounded to the nitrogen atom. So it's called N-ethyl ethanamine. Next one, a tertiary amine has 3 alkyl groups but no hydrogen items bounded to the nitrogen item. Then it's called N,N-diazoacenamine, whose formula looks like this. Alright, if you don't have any questions, next let's have a look at the properties of amines. Small amines are soluble in water since nitrogen is more electronegative than either carbon or hydrogen. So the nitrogen carbon bonds and any nitrogen-hydrogen bonds are polar. This polarity increases the strength of the van der Waals forces before molecules, so more energy is needed to separate them. That means that amines have higher melting points and higher boiling points than corresponding hydrocarbon compounds. The series of amines in figure 4 explains the effect that reducing the number of NH groups has on the boiling points of amines of similar size. Okay, then let's have a look at another type of compounds, which is called amides. Amides are structurally similar to esters, except the two chains are joined by a nitrogen atom next to the carbonyl group rather than by an oxygen atom, which is shown here in figure 5. You can compare the difference between the connection in the ester or in amide. The amide functional group consists of a carbonyl group bounded to a nitrogen atom. Carboxylic acids react with alcohols can produce esters. We have already studied this in the previous lessons, right? Carboxylic acids react in a similar way with ammonia, primary amines, and secondary amines to produce amides. We will learn more about these reactions a little later in this section. Before that, let's try to learn the procedures we can use to name and draw amides. So naming amides is similar to naming esters. The name of an amide has 3 parts. The first part from amine, the second part from the acid, and the ending, which is always the suffix amide. For example, the reaction of methanamine and butanoic acid will produce an amide, which is called N-methylbutanoamide. N-methylbutanamide, which is shown here in figure 6. Okay, did you get it? Right, next let's have a look at a tutorial of naming and drawing amides. In sample problem 1, we are given the structural formulas for 3 amides. Are you able to give its UPAC name for each of the amides here? Alright, let's have a look at the solutions. First one. First part of the compound came from a carboxylic acid with 4 carbon atoms, butanoic acid. So second part of the compound came from a primary amine with 1 carbon atom, methylamine. So the name of the amide is called N-methylbutanimide. The next one, the corresponding carboxylic acid has a chain with 4 carbon atoms, so it's called butanoic acid. The amine was a primary amine with 3 carbon atoms, so that's a propanamine. Therefore, the name of the amide is called N-propylbutanimide. Okay, next one. Carboxylic acid had 2 carbon atoms. Ethanoic acid. The amine was a secondary amine, which is N-ethylethanamine. Then the name of the amide is called N-diethylethanamide. Okay, any questions? Alright, if no questions, let's have a look at another sample problem here, which is a reverse process. If you are given the name of a amide, can you draw its structure formula? N-isopropanamide. Alright, have we finished? So the alkyl group bounded to the nitrogen atom from the amine is ethyl, right? It therefore has two carbon atoms. The carbonyl group from the carboxylic acid is attached to a propane chain. So it has three carbon atoms, so the structure is shown at right here. Alright, next let's have a look at the properties of amides. The smaller amides are somewhat soluble in water. This can be explained by the molecule structure. The NH group from hydrogen bonds with water molecules. As the length of the carbon chain increases, solubility decreases. Primary amides, with their nitrogen atoms each bounded to two hydrogen atoms, have higher melting points and boiling points than similar amides. This is likely due to more hydrogen bonding between primary amide molecules. And now let's have a look at the reactions involving amines and amides. An amine can generally be synthesized from an alkyl halide and ammonia. For example, consider this reaction here. Iodoethene plus ammonia will produce a primary amine, which is ethanamine, and a byproduct HI. Ethanamine is a primary amine. It reacts with additional iodoethene to form a secondary amine, which is N-ethylethanamine and hydrogen iodide. And the N-ethylethanamine also reacts with iodoethene, this time forming a tertiary amine, N-diethylethanamine, along with hydrogen iodide. Amines can be synthesized by the condensation reaction of a carboxylic acid with ammonia or primary or secondary amines, which is shown here in figure 7. The structure of the amide product depends on whether the carboxylic acid reacts with ammonia, a primary amine, or a secondary amine. Okay, last, an example of the synthesis of amide is a reaction of tanoic acid with methanamine to produce N-methylbutanamide plus water. Also, the reactions above are reversible. Amides can be hydrolyzed in acidic or basic conditions to produce the carboxylic acid and the amine. Okay, so this is the end of the second half of C1L4. In this lesson, we have talked about naming and drawing of amines and amides, as well as the properties of amines and amides. So make sure you complete today's homework and submit them to our Google Classroom before the deadline. Okay? I'll see you next time. Bye.